Hi everyone, Richard here. In this video I want to demonstrate how to construct a few geometric shapes, the golden rectangle and golden mean, a pentagon with a pentagram, some information that might help explain some of the geometry mentioned in these videos. So to begin, I'll first show you how to construct a golden rectangle and its accompanying golden mean. To do this, I will first draw a simple square. Starting with a horizontal line with the center point, and setting my compass to the length I'll use for the sides of the square, I place two marks, one on each end of the line. Opening my compass to a wider position, and placing the point on those two marks, I draw two arcs so they cross above and below the center line. The size of the arcs isn't important, only that they cross far enough apart that I can easily draw a vertical line through the 2 points where they cross. With my compass again set to the length of the sides of the square, I place a mark at the top of the vertical line, and another where the top of the right side of the square will be, and another crossing that to establish that corner of the square. I then draw the sides of the square, left, top, right, then bottom. Next, to find the center of the bottom of the square, important for establishing the length of the golden rectangle, I draw two arcs as earlier, one from each side of the bottom of the square, so they cross above and below the line. A line drawn through those 2 points crosses the bottom in the center. Then, adjusting my compass from that point to the top left corner of the square, I draw an arc down to the bottom line. Where they cross will be the bottom left corner of the golden rectangle. With my compass again set to the length of the side of the square, I place a mark where the top left of the golden rectangle will be. Then setting my compass to the length of the bottom line, from the corner of the square to the left edge of the golden rectangle, in red here, I place another mark at the top left. From those points in the upper left, I then complete the golden rectangle, first drawing the left side, and then completing the top. And there we have it. The significance of a golden rectangle lies in its proportions. The short side is to the long side, as the long side is to the sum of the two together. That's the same formula as the golden mean, which is a point, such as B here, placed on a line, AC, so that the ratio of the short end of the line, AB, to the long end, BC, is the same as the ratio of the long end to the whole, AC. Mathematically, that ratio is 1 to 1.61803398875, and on indefinitely. A golden rectangle cannot be perfectly measured in whole numbers. A vertical line placed at the golden mean divides the golden rectangle into a square with a smaller golden rectangle at its side. Any given line will have two golden means, one measured from one end and one from the other, D here. So those are some of the basics of the golden rectangle and golden mean. I'll talk more about them and their relationship to a pentagon a bit later. But first I want to show you how to construct a pentagon with a pentagram, just one of a few ways of doing this. I'll pare this down a bit since a lot of the methods are the same as those shown in the construction of the golden rectangle. So to start, I'll draw a circle with horizontal and vertical lines through the center, crossing the circle at A, B, C, and D. I then draw a vertical line at the right side of the circle and a horizontal line at the bottom, which cross at E. Next, I draw a line from point E to the top center of the circle, C. This line crosses the center horizontal line at F. Now, with my compass point at F, I draw an arc from C down to the center horizontal line, meeting it at G. A line then drawn from C to G is the length of the side of the pentagon. So placing the point of my compass at C, I draw an arc through G, crossing the circle at H and I, 2 points of our pentagon. With my compass point at H, then I place marks on the circle at K and J. So C, I, J, K, and H are all equal distant from one another around the circle and the 5 points of a pentagon. Then, connecting those points, I draw the 5 sides. And there we have it. It's then a simple matter of drawing lines from these points across the pentagon, like this, to form a pentagram, a 5-pointed star. Drawing another upside-down pentagram, gives me this geometry, one we will see again in future videos. A pentagon-pentagram has a quite remarkable interconnectedness with the golden mean, as well as the golden rectangle. As mentioned in my previous video, Part 5, the points where sides of a pentagram cross, marked with X's here, are the golden mean of each side. But there's more. If vertical lines are drawn inside the pentagon from the corners of the bottom side, they meet the top sides at a golden mean of each side, marked with X's. As well, those lines cross sides of the pentagram at a golden mean of each vertical line, more X's. Not surprisingly, a line drawn at the top of those 2 vertical lines also crosses sides of the pentagram at its golden mean points, more X's. This may go on forever. The more I look, the more I find. There are interesting connections with the golden rectangle as well. While doing the graphics for this video, I was surprised to notice a similarity in the way the golden rectangle and the pentagon are constructed. The arc, CG, that I drew to establish the length of the sides of the pentagon is the same arc I used, and in largely the same way, to find the long side of the golden rectangle. So a pentagon could actually be constructed starting with a golden rectangle. And I just now noticed that if vertical lines are drawn at the side points of the pentagon, and a horizontal line is drawn between those lines, meeting the top of the pentagon, and a line drawn at the bottom of the arc, those 4 lines form a golden rectangle as well. All that is to show the interconnectedness of a pentagon-pentagram and the golden rectangle and golden mean. As mentioned in my first video, Galileo is quoted as saying, "Mathematics is the language with which God has written the universe." Geometry does have an almost mystical quality, an otherworldliness. It's easy to imagine the early mathematicians being awed by geometry. The divine proportion? Exactly. I'm not sure what's next in this series, so stay tuned. If you find what I'm doing here interesting, has value, please like and follow me, and let others know. For information on my own work, visit my website at rtdavis.com. You can also find me on Instagram at Richard Thomas Davis Artist. Thanks for joining me.